And the margins are given to us as you see them here. The top and bottom 6 and sides 4. Find the dimensions of the poster with the smallest area. So we have the figure. So number 1 is done. In number 2, we have to analyze how we want to proceed. So obviously we're talking about the smallest, so they're asking us to find the minimum of an area. So I have to find the function that represents the area of the poster and minimize it. So here's a suggestion. I know that this is 384 as the area. I'm going to call this or name this X. I'm going to name this Y. So obviously I know that X times Y must equal
384.
Very good. Good. And now this is not the area in question. The area in question is for the poster, not for the printed area. It's for the whole thing. Good. Can anyone give us an idea of how to write? And I'm just going to say area 1. So it's not confused with that. Or I call this A0, and then I just call this A. Not to be confused. So, yes.
So X plus 8.
Very good. Yes.
Times Y plus 12.
Very good. That's it. So this is indeed X plus 8, and this is indeed Y plus 12. Now I have 2 variables here. Something has to go, right? So X times Y plus 12X. Oh, by the way, is everyone in the clear with this? Thank you, Sean. Is this clear? Okay, plus 8Y plus 96. So this I don't have a problem with. This is 384. But I cannot have more than 1 variable, so somehow this has to go. Is there any way of replacing that by something else from the given problem, from what we have here?
Uh, 384 divided by X.
Excellent, thank you very much. Good, so we have our 384 divided by X. And now confidently I can say this is indeed a function of X, where this is changed or replaced by 384. Of course, plus 96 in a moment, I don't really care what it is, plus 12X, and then 8 times 384 over X. 64, 69. Is this correct? Please check my numbers. Let me do this again. No, 64, 67, right?
Correct, 3072.
Okay, thank you. Very good. Okay, so I don't care to add these two, but I can, of course, because we're going to differentiate. And it will go away anyway. So a prime of x equals, this is 0. 12, of course, minus 3072 over x squared. So what? Because I will probably need to plug it in. So 8 and 1, I think it's 480. Am I correct? I think so. Okay, so then a prime of x will be 12x squared minus 3072 divided by x squared. Very similar problem. A prime of x equals 0. Of course, x squared equals 3072 over 12. And what does that equal to? What is it? Ah, very nice. And it's 16. Excellent. So 576. Please, this is a quadratic equation. I have to write this and cut it out and say only 16 centimeters. Please remember, quadratic equations have two solutions. Okay, so I have no idea what this gives. I will in a blink. Of course, it cannot be infinity, you know what I mean. Okay, so it's 16, 0. So I'm looking at this function. The denominator is positive. I wouldn't worry about it. 0 here, yes. And positive. Definitely this gives a minimum. And to find the minimum, I will have to find a of 16. So here's my function. 480 plus 12 times 16 plus 3072 divided by 16. I got 8. Am I correct? Colby, am I correct?
I don't know. I was caught back on something else I was going to ask a question about.
Yes, please.
When we were finding x squared, it was 3072 over 12. So you would just divide that, and x squared is equal. When I put 3072 divided by 12, I got 256. Am I missing something?
No, maybe I am. So say that again.
So x squared equals 3072 over 12.
Yes.
So when I divided 3072...
Yeah, it's 276. Okay.
I got 256.
Oh, 56. 256. I'm sorry. And then that's 16. Yes. Thank you so much. And that's 16. Am I correct? Was this the only error? You're correct. I'm wrong. Was this the only error?
I believe so.
Okay, let me know if there is anything else. No, I wasn't trying to see if anybody's following. No. I just remember that, and I don't know what I wrote that. Thank you. Thank you so much. So I plugged it in, and I got 864. Is 864 okay? I plugged it in here. So 480 plus 12 times 16 plus 3072 over 16. I'm checking my numbers one more time. 480, 12 times 16. Yep, I got 864. And since it's area, it will be in centimeters squared. So bottom line, the dimensions will be 16 plus 8, and y is 384 over x. So length, width, because they want dimensions. Find dimensions of the poster with the smallest area. So the length, what do I call the length? I'm not sure. Doesn't matter. Base if you want. So x is 16. 16 plus 8 is 24. And the height is y plus 12, but I haven't determined y. So y equals 384 over 16. And then I have to add 12 to this answer. So what is it? 384 divided by 16. 24 plus 12, 36 centimeters. So this piece is 36 and this piece is 24 for a minimum possible area of 864 centimeters squared. And when I multiply these two, I have to get that. If I don't, something is wrong. So 24 times 36, 864. Any questions on this problem? Okay. So we looked at the poster situation. Let's see.
Can we go back to the previous problem for just 1 second?
The previous problem or previous page?
The previous problem with the rectangular prism.
Yes.
When it came to getting the height from that, it's the 5 over x squared, with our x being
The cube root of 9
over
halves.
2, right?
Yes.
All right, just confirming that.
Yes. Yeah. So it was 5 divided by 4.5 raised to 1/3 and squared. Is that okay?
Yeah, just confirming.
I want you to. It's very important to me to make sure that there is no error.
Excuse me, Professor, where did the 30 come from?
Say that again.
Oh, never mind. I get it. Number. Thank you.
Okay. 25. Find the point. Say that again.
Sorry to keep bothering. Can you
No.
tell me how you put it into the calculator?
Yes. That 5 over. The 5 over, you mean?
Yeah. I was putting it in the calculator.
Yeah, so 5 divided by, I put parentheses, you know my favorite thing, parentheses. 4.5 raised to power 1/3. It's the cube root of this. But don't forget to square it.
Yeah, I was forgetting the square over there. Thank you.
Thank you.
I'm
Good.
good.
So 25, it says find the point on the line y equals 2x plus 3 that is closest to the origin. Find the point on the line closest to the origin. So remember, step 1, I have to draw. Okay. There is no problem here because when x is 0, y is 3. When y is 0, x is negative 3 over 2. I will graph the line. Negative 1.50 because it's 3 over 2, negative 3 over 2, and 0, 3. So this is the line y equals 2x plus 3. And this is the origin. And they're asking us to determine the point on the line that is closest to the origin. When we talk about closest, what are we talking about?
Distance.
Very good. We minimize the distance. Where is the point? I don't know. I can picture it even here. It doesn't matter where you picture it. It will fall into place. I don't know where it is. I'm going to say it's here. Of course it's not. Of course, it has to be where this is perpendicular, right? But we need to choose a generic point. So I'm going to use this point. This is point A of coordinates x. Can anyone give us the y coordinate of x? Of A, sorry.
-2. X plus 3.
Exactly. Good. So we want to minimize this distance. I am going to call it f of x. That's my distance. So this point is 0, 0. We have to remember, or if anyone remembers, how do we write the distance between 2 points? The formula.
Was that one?
x2 minus x1, everything squared, plus y2 minus y1, everything squared. X2 minus x1, everything squared, y2 minus y1, everything squared. And I'm going to call that f of x. It only has x. So the square root, x2 minus x1, but it's 0, so it's x squared, plus y2 minus y1, 2x plus 3 to the second power. And this is the distance. A to the origin.